All right, today we're looking at day 2 of Advent of Code. We got a rock, paper, scissors game going on here. Here's the prompt. I'll leave a link to this in the description below. Essentially, what's going on is you get this little piece of paper that your elf buddy drops, and it's got A's and B's and C's and X's and Y's and Z's on there. And these correspond to a game of rock, paper, scissors. It's all laid out here, but I kind of wrote some comments in the code so we can lay out what's going on with that. So let's hop right into the code. First thing I'm going to do is I'm going to read file from FS, and that file, I want to read is this input. So we have this big long list of whatever your opponent plays, and then I guess the strategy is assuming that you should play this, but we don't really know. We just picked up this little piece of paper. Let's see what we're actually looking for, which is what would your total score be if everything goes exactly according to your strategy guide. So we're writing our code with that goal in mind. All right. So some of the comments I mentioned, you got rock is represented by A and X. You got paper, which is represented by B and Y. You got scissors represented by C and Z. And then there's also a scoring mechanism where the outcome, you get 0 points if you lose, you get 3 points if you draw, and 6 points if you win. And you also get points based on what you play. So that's kind of funny. You probably haven't seen a rock, paper, scissors game like that before, but rock gets 1 point, paper gets 2 points, and scissors get 3 points. So let's dive into this strategy for part 1 of the problem. We're going to set a variable called score and set that equal to 0. Again, this is what we're looking for at the end of our code. And I'm going to go ahead and define a function called game score. And this is just going to get the score of the game. It's going to be mostly a lot of conditional logic. Like if your opponent plays something, then you play something else. So we've got 2 parameters in the function. We want to pass it an opponent choice and a player choice. And those are just going to be both strings that are, representing rock and paper and scissors. So let's start with the assumption that our opponent chooses rock. So if the opponent choice is A, then we're going to check for every player choice that we could have there. So if the player choice is X, that means player has also chosen rock, right? So we're going to return 3 for that for the game score because we have a draw. And otherwise, if the player chooses Y, which represents paper here, then we'll return 6 for a winning. And otherwise, we'll return 0 because we'll be losing. All right, now let's go with the condition where the opponent chooses paper. And for that, we'll set the opponent, if the function gets an input of opponent choice equal to B or Bravo, if you're into the phonetic alphabet or spent 10 years in the military like I did. Anyways, then we have a variety of player choices. So this might get a little bit repetitive, but player chooses X, that means they chose rock. They get 0 points for that. 3 points if the player chooses paper in this case, for a tie. Otherwise, they win and they get 6. And now let's go into scissors. It's the same thing. We got the letter Charlie, we got X-ray, Yankee, and else, which is returning 3 for the draw here, the win here, and the lose here. Okay, next thing we're going to do is create a function that returns the choice score based on what the player chooses. Remember, we've got 1, 2, and 3 for rock, paper, and scissors, so pretty simple. If player choice is X, return 1. If it's Y, return 2. If it's Z, return 3. Otherwise, we return 0, but hopefully it's one of those. And then I'm going to define a function called play game. And this is going to take in the opponent choice and the player choice as well. And what we want to do is we want to say the score from a game is game score of opponent choice and player choice. So we're just running this function for what we pass into the play game function. We're going to get a score from the choice, which is using this function right here. And then we're going to return the sum of those. Now let's define a function called runStrat, which stands for run strategy. That's not going to take any inputs, but we're going to go ahead and read our file in there, that long file I showed you earlier. If there's an error, we'll throw an error, hopefully no errors. We will define a function called games that splits on the new line. So that'll basically give us an array of strings. And it's going to be a 3-character string for each line that we have here. And so we'll set a tracker variable called score equals 0. And then for each game within that array, we're going to play the game of 0, which will get us that first character. So that'll be our opponent's choice. In the first case here will be Charlie. And then there's a space, and then we'll get 2. Game of 2 there. So we're just passing in the player choice there. And we know the play game here returns the score from game plus the score from choice. So we'll add that to our score tracker variable there. And then finally, we will console log the score. So let me save that and bring up my console here. And let's go ahead and run day 2. and nothing happened. Am I building this? Yes, I am. Oh, we need to actually finally run the function. So we got run strat there, open close parentheses, and let's give it another run. A score 13,809. If we go back, we see that I submitted puzzle answer 13,809. This, of course, will be different for you because you're going to have a different input. But let's go ahead and move on to part two. Part two, it turns out that the strategy guide we interpreted incorrectly, and this input here, this is actually represents an outcome that we want to achieve. So X, Y, and Z represent, I forget exactly which one. It says X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. And we're searching for what would be your total score if everything goes exactly according to your strategy guide. So the code's going to be very similar. We could probably adjust the code up here, but for the sake of just keeping things separate, I am going to start defining new functions. So we'll say get player choice, and this is going to take an opponent choice and a desired outcome. Let me get rid of the console down there. And we want to know if, we have an opponent choice and a desired outcome. That's what we have from our strategy. Then what should our player choose based on this strategy document that we have? This is going to be more conditionals again. So if we want a loss, in which case desired outcome is X, now we're going to go through all the conditional different opponent choices that we could have. So if our opponent chooses A, which stands for rock, then we return Z, which means player should choose scissors, right? And I'm just going to go through this. Otherwise, if the opponent chooses B, then that means they're choosing paper, and we are still desiring a loss, so we will return X, which means player chooses rock. And if we want a loss for whatever other case our opponent, which would be C in this case, he's choosing scissors, then the player should choose paper, so we'll return Y in this function. And we're just going to have two more of these kind of if-else code blocks. One when we desire a draw, so when desired outcome of get Y is input. Then we'll go through all of our opponent choices again. Hopefully this is starting to make sense. The main thing we know is that we're returning a choice this time that our player should choose, not a result. And then if we desire a win, we'll just go through the code to do that. Okay, and now I'm going to define this function called play game 2. It looks very similar to our play game 1 that we defined above, but you'll see in here we want to get the recommended player choice based on the new strategy. So we'll call a variable player choice, and we'll call our function get player choice and pass it the opponent choice and desired outcome. We'll get the game score now that we know the player's choice, and the score from game 2 is going to equal to game score of opponent choice and player choice. And notice we're actually reusing game score here, right? So we define this function up here. Where was it? Did I pass by it? Yeah, game score. So now we're just running that function that we defined in part 1, but we now have that player choice that we want. So we'll get that score, and we still need the score from the choice, and we're going to reuse our function from part 1 for that as well, because that is still working just fine. And we'll return the sum of those two variables. Okay, and run strategy 2 is going to be the same as run strat 1, but in this case, we're going to play game 2 instead of play game. We're still passing game of 0 and game of 2. Those are just those string values. And then we'll console log the score. And this time I'm not going to forget to actually call the function. Let's save. Let's open up terminal and run again. We see that we get 12,316. If I go back to the web page here, we'll see that's what I put in, and we got it right. So hopefully this helps you if you're struggling with this one here. Thank you for watching. Stay tuned for day 3, and I'll catch you in the next one. Bye-bye.
Yeah.